So, not long ago, we were all in this beautiful world of relational database. You just write your application, and it does everything for you. It does the compute, you just give a query, it does the storage, it does everything for you, right? It was all happy world. But then the big data intensive applications started coming, which kind of made it very difficult for databases to handle all these things. So we're moving to this unbundled database world where we are tearing apart different aspects of it, the compute, the storage, the processing part of it separately, and moving them into different pieces. And the also fundamental belief here is that a derived data system, if it is based on an event log, will always be much more easier to be deterministic and idempotent. That's the fundamental principle here. And then we are tearing apart these things. But at the same time, what happened is different storage, specialist storage engines came into power, right? There is something for relation database, we all know. Then we have something for search, right? Like Elasticstore or Solr, those kind of products. And there are key value stores, which are specific for certain use cases. In terms of tearing apart these, we build different storage systems. But what we need is a mechanism by which we can update these different storage systems properly. And that's why I say an event log-based system is a much better way to do that. And we can build the systems in a much more deterministic way and idempotent way. But to really build something like this, we need some kind of disruptive technologies to really make this dream possible, right? Otherwise, we are back in the same position, It's very hard to do distributed transactions or databases, but we have no different storage systems. How do you keep your things consistent across these different storage systems? So some of the properties we need for these systems are, it has to be scalable, durable, consistent, and all that. And we're going to talk about such system that we have built. And this is all in the process of what we call as making database inside out or unbundling your database to make newer applications possible, which are scalable, efficient, and fault tolerant, right? And we really believe in these principles a lot at Dell EMC. So we build an open source primitive for this. And today I'm going to talk about that. And that's called Pravega. We actually open sourced in the last Flink Forward conference, and it's a complete open source product. And I'll tell you how we kind of took care of all these features that I'm talking about. First thing is, we treat stream as a fundamental storage primitive in Pravega for the first time, with very low latency appends. And it's also used for long-term storage. It's not a temporary storage like typical message buffers are. You have two-tiered storage system there, where the first tier is very, very write efficient, very good for small writes, very good for low latency appends. But at the same time, you can do batch processing systems on top of it, because we also store in a tier 2 system. We automatically tier the data to a tier 2 data system, storage system. And one more thing that we have, what's very sacrosanct for us, was consistency. And a lot of systems talk about consistency, and there are different levels of consistency. But from ground up, Pravega was built to be highly consistent, durable, and on different failure scenarios. Unless we have all these properties, we can't build this disruptive system that I was talking about before. And I'll tell you why in the next few slides. First of all, we need a shared, durable, consistent, and onboard log storage. And that's what we do in Pravega. It's a two-tiered system. That's why we have the unbounded storage, because the tier 1 is fast, efficient, and small, but that we tier down to a bigger cloud-based storage system like HDFS, think of it, or some of the other products, or an object storage system, so that we get the unbounded storage part of it and unlimited retention part of it. The other thing is, Pravega is not based on any static partitioning. We dynamically partition as we go based on the incoming load on the system. This is a very, very important property of Pravega, and which is very well exploited by Flink in kind of dynamic scaling the applications, right? And we're going to talk about that today. Finally, we also support transactions on top of Pravega. Transactions, consistency, all these are fundamentally built from ground up. Is not an afterthought like some of the other messaging systems. Right from the ground, these properties are very, very important. Why? We want to build Pravega and we open source Pravega for one reason. We believe in these principles a lot, the derived data storage that I talked about, and it is possible to build all other systems on top of it, whether it is ingest buffer or whether it is building analytics on top of it, or even a search-based product on top of it, on a single log storage. Because of all the properties I talked about in terms of consistency, durability, scalability, and all those properties that are inherent with the system. And that's one of the single reasons why we open source, because we believe we completely open source it, we can allow the ecosystem to develop around it. Now, I'll talk about each one of these quickly. First of all, PubSub is for a log storage system. PubSub is table stakes, right? It has to support it, and we support it very well, like so many other messaging systems. But on top of it, I talked about transactions, exactly once, durability. All these guarantees are provided from bottom up on the system. So it's a typical PubSub system. It can be used just as a PubSub system. But that's not alone. We have something called state synchronizer. If you have two applications which need some kind of coordination among them, Pravega has the primitives for you to build applications. You don't need a separate system for doing state synchronization on top of it. Right? Third thing is how stream processing works very well with Pravega. As I said, Pravega really scales up, or the partitioning is dynamic as the incoming load increases. And stream process like Flink can exploit this. They can scale the workers based on how many what we call as segments we have within a stream, individual stream. And today we have a talk by Flavio and Till on this topic specifically. I encourage all of you guys to attend the topic. So as you see, not only that, because of the consistency guarantees that Pravega provides inherently, it's possible now to change chain applications and still provide consistency across different applications, right? We all know Flink provides consistency within a job, but the output of that could be, again, written into Pravega, and then Flink can consume the data, and across the board, we can provide consistency. That's the other property, which is inherently, we have worked right from the starting in Pravega. A third thing is, I talked about the other middleware that can be built on top of it, like a key value store, or a search engine on top of it. Now, what are the advantages of building a search engine? We already have a bunch of search engines in open source which are very popular. What is different with Pravega is that you don't have to replicate the data again into the storage system of the search engine. Like, if you use any of the popular search engines out like Elk or Solar, you have to pull the data from Kafka or somewhere, and then put it in their own internal storage to do any kind of search on top of it. But here in Pravega, you ingest one and mark that as searchable, then we can automatically build the indices on top of it so that you don't have to replicate the raw data again. That's the advantage. Not only that, we can also do now continuous queries, just the way Stefan was mentioning. It's possible to do continuous search on top of it, which is not possible with traditional search engines in the market, right? So this is the advantage of having an underlying log storage. One, you can have consistent data stored systems across the board, right? Because it gives the ordering guarantees, it gives the consistency guarantees. And not only that, the middleware you're going to build on top of it has this additional advantages that you don't replicate the data all over again. And now we can do continuous search and other kind of things which are not possible with static systems, where you store and search, right? So Pravega is a complete open source project, and we purposefully built it that way. We don't want to have some enterprise edition of Pravega that we're going to use. Whatever you see in open source is what we are going to use also, and we'll build other products around it. But we're going to keep core Pravega open source. Why? Because we really, really believe in this fundamental philosophy of an unbundled database, and we want to encourage the ecosystem to develop around it, right? And that's why we want to always keep. If you see most of the open source product, they have some specialized system that they give for enterprise and they sell it. We are not going to do that. We are always going to keep it as open source. Okay, so having said that, I have a few questions and give away T-shirts if you have a minute. Laura, I'm okay with one more minute, I guess. So does anyone know what does Pravega stand for? No? Has anyone visited Pravega website? Pravega.io? Okay, so it's a... Okay, I talked about one talk today, tech talk today, where Flavio and Till are going to talk about what was that tech talk about and how does Pravega help with this. Just one word about it. I talked about several properties of Pravega, including consistency, transactions, scaling, all those which are different from other systems. I talked about what is it going to do? Yeah? Auto-scaling, that's the right answer. Auto-scaling. How does Flink jobs auto-scale with the help of Pravega? Because Pravega doesn't do static partitioning. Thanks a lot, guys.